7.3, modeling data using exponential functions. The only thing that's different from this in polynomials is that we're using the regression of EXPREG. So remember, we go under, to find this, we go under Stat, Calc. I'm just going to scroll down. EXPREG. Now it's not power reg, okay? It's EXPREG. It's under mine, it's under 0. So make sure that you can know where that is. And let's launch into this question. The population of Canada from 1871 to 1971 is shown in the table below. In the third column, the values have been rounded. So we have the year here. It's a little bit fuzzy, but I think that you guys can see that. And then we have the population of Canada, remember, in millions. So what I did is I put this under my L1. Okay, this is my independent, or my X. And then I put this one under L2. This one is going to be my Y. So using graphing technology, create a graphical model and an algebraic exponential model for the data. So it just means graph it and find the equation. Let's do that. Now I have put in all of my data here, but it's always worth a check over, just so that you know that you have the correct equation. So 1871, 1881, 1891, 901, yep, we're good. 1911, 1921, 1931, 1941, 1951, 1961, 1971, good. So let's just go the other way here. 2157, yep. 18.24, yep. 14.01, yep. 11.15, yep. 10.38, yep. 8.8, 8.8 or 8.80, same thing. 7.22, yep. 5.42, 3.74, 3.23, 2.44. Good. So we've checked it. What I want to do here is I want to go second y equals to get to my stat plots, and I want to put my plots on just so I can see it. So graph. I'm not necessarily seeing anything, but let's change our window settings. We go from 1871 to 1971. Let's go 1850 for our x min, and then let's go 2050 for our x max. Let's see that. Oh, look at that. And we have a nice curve like that. Now, I think that we've got all of our data points here, but let's just check. We're going to miss that 21.57 because it's out of here. So I'm going to change that to, say, do you know what? I'm just going to change it to 50, just in case. Perfect. So what I want to do now is find that equation. So I'm going to quit and go Stat, Calc, scroll down, there we go. And then I go second L1, comma, second L2, comma, vars, y vars, enter. Now it will put it in as the first, as the function, okay? Function y1. Enter, enter. Ta-da! Now we have a bit of a wickety-wonk kind of answer here. We have 9.002466 e negative 18. That's just in scientific form. It means it's a really, really, really small number. Now if it was e to the positive 18, that would be a really, really, really big number. But I'll show you how to write it down. No problem. And then our b, our base, is going to be 1.022. Okay, so this is right here, our b is our base, and our a is our stretch factor. So it's actually not stretched, it's pretty compressed, it's smushed down. When we look at our r squared value, it's pretty good, okay, 0.98687742774. So it's close to 1. We'll take it. So the way that I want to write this down is I don't want to write y equals ab to the x. No, that's not what I want. What I want to do is y equals, and then 9.0, let me just double check on that, 9.002 times 10 to the negative 18 times 1.0, let's just double check, 1.022 to the power of x. That's it. Now what we want to do is we want to go on to the B part of the question. Assuming that a population growth continued at the same rate in 2011, estimate the population in 2011. So we need to write in the value 2011. Now in a former question what we did was we said years after 1979, and we would say 1 year after 1979, 2 years after 1979. But in this one we literally wrote in 1871, 1881, 1891. So we literally can use this value of 2011. Now we just need to deduce which one are we going to do. Are we going to do the value method, or are we going to do the intersect method? Value we use when we're given the x value or the independent, and we use intersect when given y or our dependent value. So 2011, look here, we identified here, is going to be our x. So we want to go second, and always write down your steps. Second, trace, value, x equals 2011, and it will produce an answer of y equals da 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 da. I'm gonna graph it, and I'm gonna go second, trace. Oh, still doing its thing. Oh, it's drawing our line for us. Thank you. Second, trace, value, 2011. Enter. Look at that. Y equals 5.154. 54.154. I'm just going to double check that. 54.154. But remember, don't end here. Look at the units that we used. Population of Canada in millions. So it's actually 54.154 million. Okay, so the population in 2011 is, assuming the population growth continued as it had. And we're done.